Teresa, and this is my presentation of my proposal for my mathematical modeling project. So the topic that I chose is the math behind the 3x3 Rubik's Cube. So first things first, what is the focus of this project? Well, the focus is the question, how can we obtain a mathematical model that represents the movements of the Rubik's Cube using both permutations and group theory? Further on, we want to understand the mathematical model so that we can use it to predict how the cube changes after we perform on it a sequence of moves. So in speed cubing, which is the hobby of solving the cube in the shortest amount of time, once you reach a certain stage of the cube, then you need to perform some algorithms in order to reach a fully solved cube state. The first one of it being the cross, then the first two layers, and after that you are going to get to the stages of OLL and PLL respectively. So OLL happens when you have already these two first layers of the cube solved, and then you have an arbitrary configuration of the cube on top, say this one. That's why it's in gray, because the only thing that is not going to change is the yellow one, because that one never actually moves. It only rotates, but it stays the same. So once you reach this state, you want to perform some algorithms in order to reach all of the yellows facing up. And then you can, as in this case, and once you have this state, then you want to transform this arbitrary configuration into a fully solved cube. So this one would be the arbitrary configuration where, yes, all of the yellows are facing up, but you do not have a fully solved cube. Why? Because you have scrambled top pieces. So that one is PLL, permutation of the last layer. That means rearranging the cubies that are on top, while OLL means orientation of the last layer. Why? Because you want all of the yellows facing up. Also, with this mathematical model, we want to understand why some states of the cube are considered unsolvable, such as it is the case of this twisted corner or this twisted edge. So these two stages actually cannot be solved through legal moves. What is a legal move? Legal moves are only rotations of the faces, and we're going to see that in a bit. So these two are unsolvable, but we want to explain why they are unsolvable. The math that we are going to require to understand the objective is first permutations. So we have to remember that permutations are ordered arrangement of objects, and we are going to manage, well, yes, this notation. And we are also going to focus on cycle notation. This one is going to be very useful for understanding algorithms, and with algorithms, permutations of cubies. What is a cubie? A cubie is an individual piece of the Rubik's Cube, such as these ones, and we also want to know how the composition of permutations work. Why? Because imagine that we have a cube like this one, a cube state like this one, and then you perform a legal move, say U, which is a clockwise rotation of the upper face, and that is going to turn the cube into this other state. So this one can be expressed through cycle notation, where 1, 2, 3, and 4 are the names that we choose to name the cubies, so that being the individual cube pieces. Also, we need group theory. Why? Because if we group all of the possible moves in the Rubik's Cube, then we can form a mathematical group. But in order to define this mathematical group, we need to fulfill or understand the properties of closure, associativity, identity, and inverse elements. So for closure, very straightforward, if we perform a move on a cube, then that configuration, that resulting configuration, is still a valid configuration in the Rubik's Cube. That would be closure. Associativity, that performing U and then performing U in this case, and then performing another U is the same as performing U2. That would be associativity. Then the identity element is just not doing anything at all, so leaving the cube as it is. And the inverse element would be, for example, this one. If we perform a clockwise rotation, then its inverse would be performing the counterclockwise rotation in order to go back to the state that we previously had. Now the equation that we're going to work with is called the commutator. The commutator is this equation, x comma y, defined as xy, x prime, y prime, where x and y can be either of these letters, but each letter representing a movement of the face. So if we do not have an apostrophe, it is a clockwise rotation. If we have an apostrophe, so it would be followed by the name prime, then it is a counterclockwise rotation. This equation here is closely related to the inverse, which also needs to be defined through a similar notation. Why? Because the commutator allows us to perform operations or rotations or affect cubies, but just on a specific region of the cube. That being, for example, this part here, not affecting very much the first two layers. Okay, so for this one, well, for this new video, I had to change the visual resources because that's the feedback that my classmates gave me. So now I try to use more examples, 3D-ish examples of the Rubik's Cube in order to better exemplify what OLL, PLL, and unsolvable stages are, as well as the cubies and how the rotations of faces work using a 3D simulator and then taking images from it, so that the concepts of identity or inverse element can be better understood, as well as how cycle notation is going to work. Of course, because of time concerns, I cannot explain into very much depth the relationship, the relation between the commutator and the inverse, but that is going to be explained in the rest of the repository. Thank you very much for your attention.